Hey, hello there, and welcome back for more Advent of Code. So today is 13th, but I didn't do yesterday's puzzle. I was utterly unfocused and couldn't really sit down to think. But yeah, today with already economic measures in, and I don't know, all the unpredictability about this country still there, I guess we can go back to what's really important, which is of course Advent of Code. So I was looking at the Advent calendar here. I really like how the oasis here looks in the desert island, and I was noticing that the current island that we're in, the one with pipe, maze, all the metal things, seems to have like a weird shape in the border instead of being round like the others. And I'm thinking that this sort of looks like a gear. Yeah, because it goes up to here. That would be neat, and it makes sense also in the metal, all being metal theme. So okay, let's see what day 12 is about. Hot springs, yeah, finally. Okay, you finally reached the hot springs. You can see stream rising from secluded areas attached to the primary ornate building. As you turn to enter, the researcher stops you. The researcher, okay, it's it's a link to the previous day, which I don't remember. The cosmic expansion. Yeah, that was a good one. Wait, I thought you were looking for the hot springs, weren't you? You indicate that this definitely looks like hot springs to you. Oh, sorry, common mistakes. This is actually the onsen. The hot springs are next door. What is an onsen? It's the Japanese thing from mangas and animes. Yeah, okay. Where the bathing facilities around the hot springs. Cool. So there is an onsen here. The hot springs are next door. How's that? You look in the direction the researcher is pointing and suddenly notice the massive metal helixes towering over. This way. Massive metal helixes. So are these actual springs, like springy things? It only takes you a few more steps to reach the main gate of the massive fenced-off area containing the springs. You go through the gate and into a small administrative building. Hello, what brings you to the hot springs today? Sorry, they are not very hot right now. We are having a lava shortage at the moment. Okay, so this is another chain of dependency. Now lava is needed too. You ask about the missing machine parts for Desert Island. Oh, all the Gear Island is currently offline. Gear Island, okay, so it is actually a gear. Nothing is being manufactured at the moment, not until we get more lava to heat our forges and our springs. The springs aren't very springy unless they're hot. Okay. Say, could you go up and see what the lava? Could you go up and see why the lava stopped flowing? The springs are too cold for normal operation, but we should be able to find one springly enough to launch you up there. So another mode of transportation, launched by giant springs. There's just one problem. Many of the springs have fallen into disrepair, so they are not actually sure which springs would even be safe to use. Worse yet, the condition records of which springs are damaged, your puzzle input, are also damaged. You need to help them repair the damaged records. Okay. In the giant fields just outside, the springs are arranged into rows. For each row, the condition records show every spring and whether it is operational, dots, or damaged, a hashtag. This is the part of the condition records that is itself damaged. For some springs, it is simply unknown. Okay, let's see one of these. Okay, there are also some numbers. Let's keep reading. It is simply unknown whether the spring is operational or damaged. However, the engineer that produced the condition records also duplicated some of this information in a different format. After the list of springs for a given row, the size of each contiguous group of damaged springs is listed in the order those groups appear in the row. This list always accounts for every damaged spring, and each number is the entire size of its continuous group. That is, groups are always separated by at least one operational spring. 4 hashes will always be 4, never 2, 2. Okay, so these are ranges of contiguous damaged springs. Okay. So condition records with no unknown springs might look like this. Okay, 1, 1, 3. So yeah, this is like ranges 1, 1, 3. They can have more undamaged springs in the middle. Sure. Okay, looks fine to me. However, the condition records are partially damaged. Some of the springs conditions are actually unknown. For example, okay, so this is kind of the same as before, but with some question marks. So in here it's like, I guess we should be able to tell that this is a damaged spring and this is also a damaged spring because of the 1, 1 that needs undamaged spring in the middle. But here I guess the first damaged spring can be in either of these and the second also, and this row, this one should surely be a damaged spring. This is a mess. Okay, this one is quite more difficult. Equipped with this information, it's your job to figure out how many different arrangements of operational and broken springs fit the given criteria in each row. In the first line, this one, there is exactly one way to separate groups of 1, 1, and 3 broken springs in that order. Can appear in that row. I think I missed a preposition or something. There is exactly one way separate groups of 1, 1, and 3 broken springs can appear in that row. The first 3 unknown springs must be broken. Broken, then operational, then broken. Okay, yes, it is what we already deduced, making the whole row this thing. Okay. The second line is more interesting. This thing could be a total of 4 different arrangements. The last question mark must always be broken to satisfy the final contiguous group of the 3 broken springs, and each double question mark must hide exactly one of the 2 broken springs. Neither these could be both broken springs, or they would form a single continuous group of 2. If that were true, the number of affected would have been 2, 3 instead. Okay, yes. The numbers afterwards, sorry. Since each double question mark can either be hash dot or dot hash, there are 4 possible arrangements of springs. Okay. The last line is actually consisted with 10 different arrangements. Let's look at the last one actually. So I guess this group must be the 3, and then because like there's already 3 revealed, and so that this cannot be a spring, this one cannot also be a spring, so you have all of these and you have to put a group of 2 and a group of 1 in that order here, and that is 10 arrangements. Because the first number is 3, the first and second question marks must both be dots. If either were hash, the first number would have to be 4 or higher. However, the remaining run of unknown springs conditions have many different ways they could hold groups of 2 and 1 broken springs. Nice pattern here. So yeah, this is a very systematic pattern also. It's like trying all the possible positions for the row run of 2 broken springs, and if you put it here, okay, you have then 1, 2, 3, 4, 5, or actually no, if you put it here, you need this space always, so then you have 4 places for the run of 1 broken spring, so it has 4 possibilities for that. Then you shift this by 1 and you have 3 possibilities. You shift again, 2 possibilities, and the last shift you get 1 possibility. In this example, the number of possible arrangements for each row is 1 for only 1 here, even though it has many. So yeah, I guess even this thing, although it has many question marks, is very fixed. And I wonder if that is sort of true always when you have like single question marks instead of rows of question marks. This is only 1 arrangement because the row of the run of 4 broken springs must be here. 4 arrangements here, yeah, because the 1 can be in 4 different positions here. Okay, yeah, they all make a lot of sense to me. But how the hell are we going to do this systematically? Adding all of these possible arrangements counts together produces a total of 21 arrangements. For each row, count all the different arrangements of operational and broken springs that meet the given criteria. What is the sum of those counts? Get your puzzle inputs. Okay. Ooh, look at this one. It has so many question marks. Yes, I can increase the font size. Do I lose the selection when I increase the font size? Interesting. Okay, this will require some actual thinking, and I basically have no idea of how to do this. Maybe, well, no clever ideas, I guess. Brute forcing ideas I can probably come up with. But first I want to, okay, let's jump into the code. First of all, open this and just copy the inputs, which is our usual thing. This is day 12, hot springs, and the text editor is super laggy when it's like starting up. It reminds me of past experiences with Java IDEs. Yay, nice. The input is gonna be this, sure, 1,000 lines. Whenever I get this kind of inputs that are very, like each thing is totally independent from the others, I always, like, in the back of my mind think, oh, this is trivially parallelizable. I could run this with Rayon and, you know, have nice parallelization, which is nice to have. The sample is this, but of course, like, parallelization can only get you so far. Like, if your algorithm is really bad, then there's nothing to do. The answer that we want is 21. Okay. So with these things here, one thing that I would like to know is how many in the actual input, around like how many question marks there are. So let's do a cat of inputs this thing, and then into sed, and I know that this is an unnecessary use of cat, but oh well. Let's replace anything that is not a hash. No, hash no, question mark, actually, with nothing. And if we do this, I didn't do it correctly. Maybe global is what I want, yes. And then I want to count each line. How do we do that? Well, I guess we can pass this to xars and wc. How do you count single characters? Maybe like this? No. I only know wc l for lines. Oh, chars. Character count and byte count. Interesting that this is two different things. But didn't they use -c? No, what I want is to pass this into wc, like, not as an argument. How do I do this? I could maybe use a while read this into a variable. Line, yeah, sure, do something, then done. That's something, and what do I want to do? I want to, oh, I'm not even in bash, so let's copy this, because I'm using fish shell, and I don't think that the syntax of fish allows me to do that. So let's go back to bash for this, because I haven't learned how to do loopings or interesting things in fish yet. We're gonna do wc the characters, and well, we could do just simply echo this thing, right? So echo the line. Surely there's a ways of doing this, and wc syntax, yeah, while read. Yeah, unexpected token do. Oh, I put, yeah, the do is in whatever place. It's while blah blah blah. Do this, right? Woohoo! Look at it go so slow. Calling commands like this is kind of slow. So I want this thing, but I actually want to sort it, and is reverse like this? I don't know. And then give me the top of those. Okay, 9. If I didn't, oh, this is not sorting numerically. Of course it's not 9. Damn. I think it's n, the option that, oh, 20, 19. Those are not small numbers. And I wanted to know these because, or have an idea of, so okay, the line with the most question marks is one that has 20 of them. So I wanted to have an idea of that, because I was thinking, okay, can I just brute force and check all possible, all the possibilities. So basically each question mark, let's look at the sample. The actual input is way too difficult to think of. So each question mark can be either dot or hash. So we could have like go over all the possibilities for all the question marks and see if they, generate the pattern, this pattern, and see if it matches with these numbers. Because I think like checking that match seems simple enough, like quite simple, I think. You just count the rows of hashes and you see if they are these numbers, and you can even like early short circuit that and early terminate whenever you see a run that is not the number that you want to check. or the number that you expect. And if we did that, like see all the possibilities, all the possible arrangements, we would be, of course, generating a lot of things that wouldn't match, and that would be like 2 to the power of the amount of question marks in each line. So because this would have 2 possibilities, then this would have 2 possibilities, and so it's 2 times 2 times 2, that is 8 for 3 question marks. But for 10 question marks, it's already 1024, 1K. That is 2 to the 10, and 2 to the 20 is 1 million something, 1 megabyte, like 1 mega. And actually 1 million is not, 20. Actually, it is a number that is just, on the edge of sort of what you can brute force pretty comfortably with a modern computer. So I'm now thinking that maybe it's not so unreasonable to, it's 1 million and something, not exactly 1 million, but around that order of magnitude. So it's actually probably possible to brute force this. Should I? That is one idea, I guess. A very stupid one. So you would brute force all the possibilities, then check which ones match, and count them, basically. Count how many of them match. So, interesting. That is, however, a very, very wasteful thing to do, because it's like if we think, I was looking at this example, for instance. If you're saying, okay, each question mark can be a dot or a hash, if we choose a hash here in the beginning, like that should already collapse. It doesn't make sense to evaluate any possibility for these other 3 that are not. So these other 3, all the possibilities would be 8 possibilities. But it only makes sense to evaluate 1, because you have 3 groups here to check, and you have already 2 given groups. So if you generate another little group and it's already the size of this, well, that forces these 3 to be dots. So brute forcing doesn't seem like it would work, I think, but it feels like very, very hacky and very inefficient way of doing this. And maybe I could try it just to get the answer to part 1 and then see what part 2 is about. So what else could we do with this? Maybe if I'm thinking of this too long, maybe I will pause the video and think about it offline and come back to it. So instead of thinking of all the possibilities for the question marks, it's like maybe we could think of the way that the interesting example here that had 10 possibilities. It's like, okay, how are we, like what I find very interesting is that my human mind, my human monkey brain, is, for these simple examples, is actually quite good at realizing like what the possibilities are. Like even for this one, let's try. Like it says 1, 3, 1, 6, okay? And it was only one possibility, supposedly. Only one arrangement. Why is that? Well, because the first one, I can clearly see that it must be a dot, because the first group is 1, and we have 1 here, and there's no space for another group here. So this one must be like this hash must be this, and this must be a dot. Why do I know this would be a, yeah, that's an idea, for example. I know that this would be a dot because if I put a hash, then it would start with a 2, so that is no longer, like, I don't have to evaluate anything else. So maybe that could be an idea of, similarly to what we were saying, but instead of blindly checking all of the, like generating all of the possible patterns, like you can go in order and say, okay, if there's a dot here, then okay, this could be a possibility. But if there is a hash, then that's it. There's no possibility here. Discard all possibilities that start with hash, and that already cuts, you know, the huge possible like set of arrangements, cuts it in half, because you just discarded like half the universe there. So that would be, I think, what makes sense. And once you know that this is this group, then the next one must also be a dot, because otherwise, again, this would be a group of 2 if you put a hash there, right? So then you had dots up to here, then you have a hash, and actually once you know that you have up to here, it's like, okay, I have solved up to the first digit, and I can forget about the first digit and the first hash and the dots. Although I'm not really sure about what I'm saying there, because when you can move things around, maybe this is not true. But this hash must be the start of this group, and if this is the start of that group, then we know that there are 3. Like this one is all can collapse already to a hash. There is no possibility that this is a dot. Awesome. And since this is a group of 3, and it's already complete, like you cannot shift it around or anything, then this is also a dot. Great. Then we can follow the same idea. This will be a group of 1, and then it finishes, so this is also a dot, and then it starts the group of 6, and this is 5. So all of these question marks must be hashes. So there is one, only one arrangement. And it's interesting, like how sort of our human intuition can see this, but making a general algorithm for this, at least to me, it's not very evident of how it would be. Okay, but that's sort of an idea, right? Like going and seeing, okay, let's think about that idea, but for an example, this is also fixed, because even though there are 4 question marks in a row here, it's like, well, again, my human brain that is trained to like recognize patterns, immediately sees, of course, that if you were to consider to put a dot here, then the 4 doesn't fit anywhere, because you need to have at least 4 spaces for that. But how could we express that in a formal way to avoid trying the possibility of putting a dot there? So maybe the correct way is to go the other way around. Think about this number instead of thinking about what the question marks could be. We could ask the question of where could these rows of or runs of damaged springs, where could they go? And if we make that question, it's like, okay, this row of 4 can only go here. How do we know that? Well, because yes, this could all be, like, we can say there is an arrangement where that is possible. And okay, and then the rows of 1s are already fixed. This the row sorry, I keep saying row, but I mean run of, because these are runs or contiguous groups. What is the name that? Groups or something. Contiguous group. Yeah, let's call it group. The group of 1, there's 4 different places. Like, okay, it could be here, it could be here, it could be here, or it could be here. And one interesting thing, okay, and let's think about. What I'm thinking is, okay, when, like, this is the interesting example. We have the 3, which we should be able to fix in place. But then the group of 2 that comes afterwards, like the first group of 3 should fix all of these characters. This should be a dot and another dot. Great. And so then the group of 2 has freedom to move in this range, but not in all of that range, because also the group of 1 would, you know, eat these 2 spaces for the spring itself, and then for the dot to separate it. So the group of 2 actually would be able to move only on this range, which has 5 question marks, and so it has like 5 or 4. Wow, it was 4, right? Yeah, and why is it 4? For the separator, I guess. So, oh no, it's 5 question marks, but the group length is of 2. So you have 4 places to put it in this range. How the hell do we express that in an algorithm? I have no idea. We could say, okay, the 2 can go here. Then if the 2 goes there, then the 1 has these 4 places to go, so 4 possibilities. But if the 2 goes here, then the 1 has 3 possibilities, and so on. If the 2 goes here, the 1 has 2 possibilities, and if the 2 goes here, the 1 has 1 possibility. Could that be a general thing to do? It feels like a much more complicated algorithm to do that. Then, of course, the brute forcing way. What I'm thinking about, though, is sort of not a combination. Like what I was last thinking about just till now was to sort of try to see the places where we can put these numbers, like starting from these numbers and seeing, okay, where can I fit them in the patterns? Okay, that seems quite complicated, difficult to think for me. I'm also thinking if there is like very like mathematical ways of like using combinatorial maths to just say, oh, you know, here you have this many spaces, so this is I don't know, a 3 choose like n choose k function, and just do a simple math factorial like calculation, and that spits out the correct result. I wouldn't be surprised if that is the case, like if it's very trivially solved by understanding maths. But okay, but I'm thinking about the first approach that we are thinking of. Okay, what are the possibilities for the question marks, but making it a tiny bit more intelligent and saying like instead of generating the whole pattern at once and generating all the possibilities for this pattern, this would be 8, but this would already be like 1, 2, 3, 4. Let's see, 1, 2, 3, 4, 5, 6, 7, 8, and 9. So this is 512 possibilities for this pattern already, and this is only 9 question marks. We know that it goes up to 20. But if you go in order, it's like, I think it should be possible to say, okay, if we put a dot here, is that possible? Yes, because dot and 3 hashes is consistent with this. We don't need to know about these unknowns yet. That is consistent. Okay, we keep going and generate all the arrangement. I mean, count all the possible arrangements for that branching. But if we put a hash here, it's like, no, it's impossible to match this. So we shouldn't count any of that. That is an impossible arrangement already. We can skip, these are 8 question marks, we can skip 258 possibilities if we just discard at the beginning. So I think I would like to implement that sort of logic. Okay. How do we do that? I don't know. This feels like a very abstract thing for me to think about. Like I feel like I'm pretty good at things that are like simulate things moving around and so on, like the freaking cosmic expansion of last time. But this kind of thing of like abstract math thing is like, man. Okay, how do we even go about this? Okay. What I... Yeah. The modeling of this, I'm thinking of like using an array of maybe an enum of 3 possibilities, like dot, which meant operational string, hash. But I mean, I could use that or just use a string for this, and then a list of numbers. And I'm sort of tempted to start with that. So let's do that first. These are basically the lines of this. Let's report lines. Report was the... It's not report, what is my input? Records, okay, yeah, let's say these are records. Are gonna be the input lines, and we are gonna map to something, and we're gonna collect into a vector of these things. And let's just say try collect, yo. Come on. Sorry. Try collect. I wanted to do it with autocomplete so that the thing got auto imported. So this would be a vector of things. And let's just generate a little function here. Parse record of this line, sure. No. Okay. Here I want something like this. What is each record going to be? Well, let's just make it a tuple of a string slice and the vector of numbers. So these are all small numbers. Let's just use I don't know, is it okay to use bytes? I mean, they are small numbers. Yeah, why not? Although it seems like an unnecessary optimization. Let's just use 32-bit numbers. It's not like working with bytes makes anything faster on modern computer, I think. And of course here I want to early return this. So I feel like I'm a bit unfocused already, and this is the kind of problem that I have trouble like imagining a solution right away. But it's a nice practice, you know. It's like, okay, yeah, I have to get good at this kind of thing. So let's say we're gonna split the line into two. Split once, and this is just a space, right? Yeah, okay. So this already has the first part of this. Yeah, it's the row of springs. Springs row, let's call it, and the second part are the group numbers. Yes, those are actually okay names. Okay, or invalid input. Blah. Early return. And then we can say, okay, and that's basically what we want, basically. And I'm going to bite the bullet and say, hey, you know what? Well, let's just return the springs row and the group nums, and I'm just going to extract a function here to say parse numbers. For this group numbers thing, names generate parse numbers function, yes. And this is just going to take a string and it's just going to return a vector of numbers. Okay, yeah. And for this case, I just want to have split by commas. So s split by comma, and we're going to map parse and collect. And you don't like this because, yeah, sure. If we do this, it's like parse will give us. Why is your problem here? Yeah, the actual, like if I want to get rid of this thing, it's like I would have to use this operator to convert the result of parse into, or the error kind of parse into the error kind that AOC result has, which is a dynamic error, and then wrap this whole thing in OK. Oh, this didn't work. I thought that was going to work. Yeah, and I even have to give the, now it seems like it cannot infer the type of this, so quite annoying. And come on, it's like what's your problem here? Oh, we even need to say, okay, this would be what makes this thing work. It's like ugly. We could extract this into a variable, which might make things happier, but still the parse doesn't know what the numbers should be, even though for some reason Rust Analyzer sometimes seems to be more intelligent than the Rust compiler itself to figure these things out. So we still need to say parse what and parse this. And how do we... Okay, all of this is just to convert the types of errors, but maybe in this case I don't need to convert the types of errors. This would give us a parse int error. Let's just return that, return a result of this and parse int error, which we can import. And this now compiles, and for some reason this doesn't. Oh, it doesn't, because here this error at least now does make sense. I need to wrap this thing into an OK, and that is fine. And I was extracting this stupid function, which I could totally have inlined here and have no problems, because we have already done a few times this thing of parsing numbers, and it's something that I really would like to have in our shared library to reuse. Oh, and this here result is shadowed by this, so let's say this is result from the standard library, and this is well, this thing. Sure, we can actually maybe import just num and say num this thing. Sure. And now this thing lives in AOC. And okay. To do make this reuse this on other daily solutions. Okay, so other daily solutions that need to parse numbers, we should reuse this function. And I know that on other days the numbers were not separated by commas, but it's fine for this. We can make this function more generic when need be. Let's actually print what we got. I don't expect to have an error on here, but well, if I can type, this is not results, these are records of things. And we can close this and say cargo run, same as this, but with day 12, hot springs. And what? What did I do there? Oh, I think I control V or something. Okay, sure. The parsing seems okay. So now, can I sketch out some solution for this thing? It's funny. I'm already 45 minutes into the video. I have in a stopwatch, and I only parsed the input. And really, I have no idea how to approach this thing. But okay, let's do. What should we do? Let's go with this idea of, okay, I'm going to evaluate each question mark in order and see, okay, if the thing is a dot, can the what I have in the pattern still work. That seems reasonable to me. Yeah, sort of reasonable. And yeah, let's try to do something like that. Okay, so what I'm going to, let's write the high-level code here in main. So we're going to say that the answer to part 1 is records. We're gonna iterate them. We're gonna map these things to some function that we are going to do, which will be like you can have the things row and groups, and let's say count arrangements, or count, yeah, possible arrangements, why not, for this row and these groups. And then we just sum these things, right? This would be like the, I don't know. Let's just first generate this function. Okay, the possible arrangements. You know what, since we can maybe generate, well, I don't want to think about number types or anything, just use 32-bit numbers, and if we overflow, we will know and we will increase this thing. Yeah, count all the difference. Okay, so arrangements sum, let's say, and this is what we will print in here. Println, just print this thing. Okay. Now, this is the meat and potatoes of what we need to implement. So, what I think I want to do I want to make this thing sort of recursive? I think I do. It seems like an overcomplication, but actually no, because I want to sort of like count arrangements, and I can delegate to myself like in a recursive way, instead of trying to keep things in local, like create a stack or something, because we like think about the some of these possibilities is like the one that is interesting when if we make things right, we are going to say, okay, let's count the let's start with this question mark. Can this be a dot? Yes. Then count the possibility, the arrangements for the rest of the thing, and well, do that, and then we are going to ask, okay, can it be a hash? But no. Then the answer is just the arrangements that we counted. The same is going to happen with this, because this cannot be a hash. But when we evaluate this one, we are going to say something like, okay, can this be a dot? The answer is yes. And so if this is a dot, then what are the, like, count the arrangements for the rest of this, like, assuming that this is a dot, for the rest of this thing, and then yeah, and then we ask, okay, can it also be a hash? And the answer is yes, because it is a possibility on this. So then count, assuming that it is a hash, count the arrangements on the rest and add those things up. So it's like we have this branching of things, and we could use like a stack variable, like an actual stack. I mean, a vector where we push and pull things from, push and pop things, like stack variable, but we can also use the call stack to manage that for us. And generally, I find like recursive ways of thinking more approachable. So now I don't know if how are we going to do the recursion itself. Let's sketch this out and think about it. So first, I want to find the first the first question mark. So let's say row. There is no index or position thing for this, so we have to actually iterate the row and find the let's leave the 2 here at the end. Don't you have a position method in iterators? Oh, this is a string slice. We don't have an iterator method. It's chars what I want. Yes. Okay, now we have the chars. And having chars is actually like, do I want this? I don't want to think about characters actually. I'm going to return this as bytes. And just think about single elements, because like chars can be multiple bytes, and that is something that I don't care about in this case, because it's all ASCII. So as bytes, why don't you like this? Because no, this is not a reference to a single byte. This is a slice of bytes, of course. Okay, happy now? Yes. So we can iterate this, and we're going to find the position of the first the first question mark. Okay, so which there might not be none, and if there are no question marks, what does that mean? I think that is our recursion stop condition. So let's say let question index unknown is what this means. The first unknown spring index. If there is none, this is an else. If there is none, I think we are going to say either return 1 here, so it's one arrangement only, which I think is fine. Because it means that I'm not sure if this is fine actually. Or we are going to have to check if the row matches these groups, like to say 1. Maybe we have to do that, but I don't know. Okay, but in the general case, what do we need to do? Well, this is the index of a question mark. So my idea would be to evaluate both possibilities. So like evaluate if it is a dot or if it is a hash. And how are we going to do that? We can, these are the groups of damaged springs. we could mutate this row, or we can just generate a new row with this thing replaced. Yeah, with that thing replaced, which might be simpler to do. Let's say this can probably be done better with mutating the actual thing, but let's do row. I don't know if clone is what I want, because I probably want to do okay to vector thing. In fact, Clippy is saying, hey, clone reference in this situation does nothing. Yeah, no, I don't want clone. I want something like to vec or to owns or something like that. So now this is what I want, and I'm going to just mutate it and say, okay, if the new row at the unknown index is a dot. And now I want to ask if this new row is possible with these groups. And if it is, then count all the possible arrangements given this new row. Right? Something like that kind sort of makes sense. Let's say let's let's count be 0. Again, this is a mutable thing. And in the end, we're going to just return count. Sure. So if is possible, just is possible, this row, this new row, given this group's numbers, if it is possible, then we are going to count possible arrangements for this new row and the same groups, and we're gonna add that to the count. Something kind of sort of like this, right? Yeah. And we don't need to worry about mutating this thing, because count possible arrangements doesn't mutate the row it receives, so this is fine. I'm wondering if it would make sense to slice the row itself and the groups, but that seems sort of kind of like an optimization, I don't know. But now let's also consider the hash possibility, and if it is possible, we can mutate this because we own this new row thing, so this is fine. We don't have to generate another one. We count the possibilities of that, and okay, this seems reasonable for the main recursive idea, I think. We are only going to count the things that are possible. Okay, and now actually all the interesting logic is going to be on this is possible function. So here we're going to have a row that has both, that can have question marks. So that's what we need to answer, basically. And how do we do that? Right? Because let's actually say something. I want to do something very stupid here. Let's say true, which is wrong, of course, but let's say true there for a second. And here I want to count these possible arrangements, blah 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 blah. Let's also let's put this into a little variable, and I want to print possible possible. Let's print the row here and the groups. No, this doesn't receive expression, so yeah, just put the groups there, and possible arrangements is C. Okay, and the row is row is going to be string from UTF-8 of this row. Okay, don't like, come on, why don't you like this? String doesn't look like, oh, because it's a result. Unwrap, of course. Unwrap, of course. And what do you want here? Double reference. Dereference once, maybe? What was actually needed here? Oh, it needs, because this takes ownership. Come on. You're making this too complicated. I don't care about the extra allocations, of course, here. I just want to, like, I know that this is stupid, but yeah, I wanted to see these numbers, these powers of 2. So at least I know that the recursive function is doing what I expect to do so far. So okay, that's good. Now, how do we know if a pattern, if a row is possible for these groups? Well, one thing that we could do, how do we actually know this? This is not, this won't be as simple as I think, because again, like human monkey brain versus what is easy to implement in logic. Okay, let's go thinking like one by one. Let's maybe start with the simplest case here. We are going to try first with the dots, right? Yeah, which should be impossible here. Should not be possible to put a dot here. Why? Well, we already have a group of 3. Maybe we can do that, right? At first, extract the groups that you already have. Like, okay, this must be this 3. Sometimes you don't have that information. Like, what can this thing hold? Well, it can hold a group of 1 and a group of 2. And if it holds a group of 1, then, but it cannot hold a group of 2 ones, which is what we want. Okay, so how do we say that this is impossible? Because if we cannot say that this is impossible with a dot here, then we are going to evaluate the possible arrangements with the dots, and there is no case that this returns a 0, and it must be 0 because we are returning 1 here. So How are we going to do this? I am kind of thinking of brute forcing this thing. And the brute force, like we can use a similar, I don't know if you can hear my cat. Sorry, I'll be back in a second. What was the pausing shortcuts? This? No, not this. Okay, I'm back. So, yeah, my cat wanted to open the closet door because she likes to sleep there, and of course I had to make her the favor. So, where were we? Okay, I was thinking of the possibility of just YOLOing and trying to brute force this thing. I think that we can use a similar approach here, a similar approach to what we did, but when there are no question marks, no unknowns, we actually check and see and say, hey, if, yeah, this might be actually not too terrible, and I'll explain why. We might get to a position, okay, sorry, let me explain what I'm thinking because I'm sort of going ahead of myself. So, if this is possible function was perfect, and perfect in the sense that, okay, it only says true when there are actually possible arrangements that for this pattern that includes question marks given these groups and gives you no false positive. So it doesn't say true in any case where it's actually not true, where there won't be possible arrangements, then this would be fine. So when there are no unknowns here, saying, okay, this is the only possible arrangement here, and it is a valid arrangement. But we could, instead of saying, okay, is it possible, maybe this could be more of an heuristic thing, and it's, well, maybe the name would be not very correct, but I want, if I only want to say, okay, let's not consider this when I'm sure it is impossible, when it is impossible that this pattern matches this group, but I'm not sure if it, when it says true, it might be false, but I want it, when it says false, to actually be false. So that would mean no false negatives. If this thing gives no false negatives, then it's fine. Like, we know that when it says false, it's like, okay, then there's no possibility, but there might be the possibility that we reach, like we find no possible arrangement, that this thing might return 0, but that is okay. And I think that's where I'm going to go. But if we do that, when we reach the cutting condition, we have to check if this row actually matches these groups. That's what we want to check and return. And if it does, then return 1 in that case, otherwise return 0. And so therefore this would be more of a heuristic and say if is impossible. I'm going to sort of say this, and it's not impossible, man. It's not impossible. Okay? Something like this. If it's not impossible, then count it. But otherwise, here we want to check. Say matches Yeah, row matches this row and these groups and matches SU32, and this will just be a function that returns a bool. But now we know that the row here, row doesn't have, that it doesn't have sorry, I'm thinking, unknowns. Okay. This is sort of like an early termination, fine. The thing about this is okay. And let's just think about when a row that doesn't have question marks, unknowns, matches these groups. So I think what I want to do is something like row. Is there a split? Yeah, kind of. Split with a functions. Yeah. So what are we going to have? I want to split by the dots, basically. So B equals dot. Okay, something. Is B the correct type here? Sure. I want to split by this. This is probably going to return empty. Let's say false here, so it doesn't bother me. I want to probably filter the things that are empty, so yeah, let's first have this idea. Man, I am very unfocused today, I think. Again, so print line splits. Splits are this, sure. Let's actually call this, because we're going to have a lot of oh, and these are bytes. That sucks. Wait, though, is this? Yeah. Let's have just row matches a row of. Let's get one of the examples here, or let's get one of this. I want this. Yes, this is. No, I don't want that. I want this one that has multiple dots. Yes, that's a good example. This, and just have a empty slice for this. I don't care about that, and let's return. Okay. Yeah, don't complain about that. Row matches. Oh, this. Okay, the bytes, of course. Okay, yeah, the splits are this, so some of them can be empty. That is fine. We can filter them out. So filter by these are like, well, slices is empty. we want to filter the ones that are not empty. So we run now, we have these splits or these sub slices, okay, and this is an iterator, so it's a lazy thing, so it is exactly what I want, and I want that these exactly match the group numbers that we receive here, okay. That is what we want. That is what we want. And yeah, and we want them to match all. So So how are we going to do that? I was thinking of, okay, we can do this. Now we have the correct thing. We can zip this with the groups and then ask if they all match the condition. So these are hashes runs, and the hashes mean broken spring run, springs run, and this is group number, and we want to ask if the broken springs run length is equal to this group number. Okay, something like this, group number. Sure, yes, but this is the wrong size. Sure, don't make me think about numeric sizes now. The problem with these, however, is that when we zip, we take the other thing, yeah. But if the zip is like it iterates over the both things, but if it doesn't consume all, like we also want to check that we consume all the groups. That's the thing. So how do we do that? I think I'm going to just use a more simpler loops, a simpler loop for this, an early terminate, something like that, and we can then also check that we have consumed all the groups, right? It sort of makes sense, yeah. It doesn't match, we say false, yeah. But this is basically the logic that we would like here. And let's say the thing is I want to consume all the groups. Sure. We could collect the splits, but I mean I don't want to do extra allocation if it's not necessary. So let's, yeah. Let's do something like this. I'm going to grab these, which are broken spring runs. It's an iterator for those. And then write the for loop. So we're gonna go for each group number and broken spring run in groups iter zip I want to also count how many of these we go. So maybe something like this, and enumerate, kinda. Broken Spring runs, we're gonna zip this with our groups, which is what we were doing here, I guess. Yeah, sure. And we are also going to enumerate this, I think. Yeah. Okay. And so here, we're actually going to have, but instead of enumerate, I'm just going to use, yeah, let's not do this. We're gonna have the Broken Spring run and the group number, and let's just use a good old counter. So groups matched is going to be 0 at the beginning, and we're going to say, okay, if the Broken Springs run length is different than the group number, then we know for sure in this case that this doesn't match, so we can just early return false here. Okay, otherwise we're gonna say groups matched, increment this thing, and in the end we want to check if the groups matched equals the groups length. Okay, that sort of makes sense to me. And this, of course, wants to be a user size. And okay, we can actually now run this against what we want. So we want this to match when it is 1, 6, and 5, right? So if we say 1, 6, 5, let's this thing be a Boolean. Row matches B. Let's run this. Yes, it matches, of course. But if we add another number here, what about that? No, it doesn't match. Oh, and what happens if we match partially? I think I didn't check this case. It says true, but it should say false. Shit, okay. We want to have the iterators zipped exactly. They should end at the same time, which is a bummer. Okay, but we also want, so this thing should match, but what if it says a different number there? Then it says false. Okay, that's good. If it says a different number here, it should also say false. Yeah, this is a unit test. Test-driven development in its maximum expression. So, is there something like a hard zip, like Broken Springs thing? Oh, look at this, zip EQ. Does this come from itertools? Yes, it does. Creates an iterator which iterates over both this and the specified iterator simultaneously, yielding pairs of elements. Panics if the iterators reach an end and they are not of equal lengths. I would really like this, but not to panic. Not to panic, but the problem is that this is, since iterators are lazy, I think it's gonna be difficult for that to be the case. Zip longest, what does zip longest do? This is also from itertools? Yes, of course. Pairs of two optional elements. Yes, this seems, yeah, this is what I want. Zip longest, which gives us optional things, but that's fine. Zip longest, these should now be why don't you know about these things? Either or both. Oh, it's an iterator with systems of types either or both. That's interesting. Let's see their use. Both. So either both. Yeah, open this. Both left or right. Yeah, so when it is both, we do the comparison, but if it's anything else, then we should say false, right? If it's left or right, then one of the two didn't match. Yes, exactly. So that's awesome. This is what we want to extract when it is the both case, but say, I don't know how to call this thing, but let's say lm and match this lm thing. Okay, and please give me this. This is great. This is great. If we have both the broken spring run and the thing, we want to ask if they are equal. Yes, and in either case, either or both. Can you, oh, come on, I want to have this thing. So itertools, blah, blah, blah. I want to also have this guy, either or both. Well, we can have some name spacing here, I guess. Or yeah, sure. In either the left or the right, we want to say false, but then we don't. Yeah, we don't care about this. So I think we can go back to our we should be able to go back to our iterator like nice thing. We want to ask if all of this yes, zip pair, let's call it, match something like this, and then we want this condition still. Okay. If they are both present, then we want them to have the same length, sure. And in either of the other cases, left or right, we're gonna say false. Because that means that that the iterators have different lengths, and that's what I don't want. Okay. Here we are going to match this guy, and actually I want, give me just all of this, both left and right. These are fine names to import, I think. Okay. Yeah. Does this work though? So it says false, set false before for, well, this is the case of 2, so it should still say false, yes. This is the true case, yes. But now if this is smaller, it says false, great. And if it is larger, it should also say false, yes, great. So now the row matches function seems to work correctly, at least I think so. And we are asking this. I thought that this was going to be much easier to implement, but okay, I think we did it. We don't know. We always say that things are impossible. Is it impossible? No, it's not impossible, so it is possible. I don't know if the name impossible is the greatest. But look at that. I think those are the correct answers. Those are the correct answers. Yes, and 21 is the correct answer for this, but we are brute forcing everything, basically. I actually don't like this name is impossible that much. I'm going to go back to saying is possible and say true here. And run this. And okay, I think I want to run this for the actual input, which is going to probably take a long time. Let's see. It's not taking that long. And this is running in debug mode, so, and this is brute forcing everything. Man, I think I how do you say? Like I thought that this was more difficult, and okay, yeah, that was the answer to part 1. Damn, this was hard to do, but here I'm brute forcing everything basically, because this condition that I want to say when this is false is surely false, like it is impossible. Yeah. I want to be able to say that, because since we are going from left to right, evaluating all of the question marks, I want to be able, whenever I already formed some group that is impossible because like it doesn't match the first group number, for example, or the second, like whatever, however many we have matched, then I want to be able to say, okay, this is impossible, like short circuit and finish things faster. But let's actually like not care about that. And if we run this in release mode, it runs pretty fast actually. So like even for the actual input and for all the possibilities. So man, I think I was like overvaluing. I'm making like I'm having a blank for the word I want to think about. So valorando. Okay, I was thinking that this was more difficult than it actually is, basically. Part 2. As you look out at the field of springs, you feel like there are way more springs than the condition records list. Okay. When you examine the records, you discover that they were actually folded up. this whole time. Ooh. Now it's going to get pretty. To unfold the records on each row, replace the list of spring conditions with 5 copies of itself, of spring conditions, separated by a question mark, and replace the list of continuous groups of damaged springs with 5 copies of itself, separated by commas. So this row would become this. Now it was very like folded up. Okay. The first line of the above example would become this mess. So now, okay, now brute forcing surely won't work. In the above example, after unfolding, the number of possible arrangements are still 1, but this, yeah, we're getting bigger numbers. After unfolding, adding all of these possible arrangement counts together produces this big number. Unfold your condition records what is the new sum of possible arrangement counts. Okay. Great. So this is the answer for our sample outputs that we want. We are, yeah, okay. I think, well, I think I want to stop because it's already 1 hour and 40 for a video, for a sitting, and I'm already quite like dizzy thinking about these things. But I would maybe like to try to generate these unfolded things, like unfold these inputs and see what happens. Like what happens with this approach, if it even works for the sample input, or if it will just be completely unfeasible. So let's actually leave this printing here. I'm going to input lines, yes. So we have these lines. So the unfolding means grabbing this, multiplying it by, repeating it 5 times and joining with a question mark. And this basically do the same thing. And yeah, unfolding and joining with a comma. So, okay. I guess we can have the records and say, okay, unfold the records and do the same thing. So I can grab these maybe, extract this into a function and call this count arrangements, count possible arrangements. Okay, possible arrangements sum. Okay, and this is this, of course. Let's say answer to part 1 is this, and the answer to part 2 is gonna be same thing, but with the unfolded records. So yeah, we can have the records here, whatever, yeah, whatever, and let's say unfolded records is gonna be unfold, or just say records unfold record. Collect, sure. We we can consume the iterator here because we don't need the original records anymore. And do this. Okay. We are going to, well, parse record. Let's put it here. How do we unfold a record? So we are receiving this. This might not be as simple as it seems, because, or at least not with the types that I introduce here, because I will need to generate new strings and things. So like this cannot be a slice. It will need to be something that holds, that owns those bytes. So okay. So this unfold records should should return like new records or just alter the ones that we have here. But even those are like questionable, I think. We could even like do this as strings, to be honest, and unfold the input itself and just do this thing again. Yeah, why not? Maybe that's simpler. We're just going to do the same. We are going to do parsing, but that is fine. These are going to be the unfolded records. And we're going to also have like an unfolded input. And what we're going to do is unfold the input and just pass in the input itself. Okay. So we're not going to have this. We're going to have an unfold input function that takes the input as a string slice, but it's going to return a now owning string, and this we're just going to say input lines, unfold each line, and then join with new lines. Basically, we're gonna do all the work again, but meh, all the work of parsing again, but I don't care. And this, how do we unfold a single line? Well, we are going to have the line itself. We're going to do something similar to when we were parsing, that we want to split the line. So sure, something like this. We're still going to need, and for now, I don't want to care about errors there. Join the arguments. Yeah, okay. You will be able to join, don't worry. So the springs row, we want to multiply this by 5, right? And these are numbers that I want to join by... okay, so let's say let new row is gonna be repeat from iterator repeat. Isn't there like a repeat n? Let's use repeat. Springs row, take 5, as the song says, and join with a question mark, right? Would you be happy with this? Not really. Did you mean to write? Maybe I meant to write this. Okay, this seems fine. And then the group, new group nums is going to be same idea. There's surely better ways of doing this, but group nums, we're going to join by commas, and we're going to return a string with these two, new row and new group nums. Okay. We don't like this because new group nums. Okay, and to join, I guess you want an actual string here. Okay, are you happy with this? Unfolded input. Yeah, passing the input as this, and this of course is going to be this. Fine. And does this work? Let's actually run for the sample first, of course. Well, it did calculate the possible arrangements for the first thing, but it's taking its read time for the second one, which is this number of arrangements. But this has 2, 4, 5 question marks. Multiplied by 5 is already 25. So that is 25 is 5 is 32 million, 32 mega possibilities. And they are also joined by question marks, so that is 4 extra. It's like almost 1 giga of possibilities, or like half giga possibilities. So the yeah, this approach, and we are running in release mode also, so that was taking a lot of time even in release mode. So this approach is clearly not feasible for part 2. I am surprised that it was feasible for part 1 actually, and that it was quite fast enough, but for part 2 this is really not going to cut it in any way possible. If we run with the actual input, we're going to have the 1,000 first cases, and then we have the first of the new unfolded cases, which has 32 arrangements, but well, the rest ones are going to take way too long. So we need to find a way of cutting this branching of possibilities. And well, my idea will be to implement this is possible, like heuristic function that shouldn't be too complicated to do, but well, I need to be a bit more fresh to try this out. So yeah, I will cut this video now and maybe follow this up today at night, because I want to go hit the climbing gym or something. So that will be it for today's for this video. If you have been, thanks for watching and see you later. Bye bye.